Hi guys, it's me, Mr. Broder, and good evening to you. Today we're going to get a little preview of what we're going to be working tomorrow in class called surface area. So before we begin, there's a few things that you're going to need. You're going to need some paper and a pencil because I'm going to ask you to stop the video at certain points and work out some problems. And you're also going to need to pay attention because tomorrow morning you're going to have to do a journal topic right at the beginning of math class, and that journal question will be a little bit later in this video. So why don't we get started? So the first thing that you need to know is that surface area is something that you're going to be dealing with all through your life as a mathematician. It's not just something we do in 5th grade. You'll find it in high school and college and eventually in the professions that you go into. It can be used for anything really, from, if you had a gift that you wanted to give to your friend and wanted to wrap it, you'd need to know surface area to know how much wrapping paper you needed. If you were going to paint your tree house, let's say, you'd want to know how much paint to buy in order to cover all the surfaces. Or later on in life, if you were going to be a clothing designer or a chemist, certain molecules you'll need to know the surface area of. A gardener will need to know surface area to put the correct amount of soil in a box. Even dentists need to be concerned with surface area, so they put enough, let's say, resin on a tooth, or for tooth replacements, whatnot. They use it too. So surface area is important. So here we have a very SpongeBob-y looking square right here, and the first thing that you're going to need to know about surface area is that it is about finding area, and we're kind of professionals at that, aren't we? We know how to find the area of two-dimensional shapes like this square. So if I were to begin by just giving this square a measurement, okay, you ought to be able to recall how to find the area of the square. Now, knowing what you know about squares, you know that all the sides of a square are congruent, meaning they're equal in length. And so, using your geometry formula, you should be able to find the area of this square. Now, obviously, if all the sides are congruent, then these are all going to be 6 inches long. And for finding the area of a rectangle, which would be area is length times width, the square is a type of rectangle, we would simply take the length of the square and multiply it by the width of the square. And so we would get an answer of 36 inches squared. That's important because we're talking about the space inside of the shape, right? The area inside of the shape, not the distance around it. Now, because it's a square, you could really just say that the area is one of the sides squared because you're multiplying it by itself. Okay? We remember that. Here's a different shape, though, and I don't know, we've done a few of these before as well, so maybe you could stop the video right here and scratch out what you think would be the area of the thing. Now, before you begin, I should say that you probably want to consider this to be two shapes. So if I drew a little dotted line here, maybe that changes the picture for you a little bit. And maybe it makes it a little bit easier to recognize how to find the area of this shape. Go ahead and try it now, and I'm not going to give you the answer, but I will be checking the answer tomorrow in class. So go ahead, pause the video, work it out, and then start the video again, and we'll go on to the next page. Okay, well, if you're back, I hope you were able to figure that one out. I want you to keep in mind how to find the area of shapes as we move into the next part. Now, today in class, what we talked about was polyhedra. And polyhedra, if you remember, are solid figures. They're like the shapes that we see in our day-to-day lives. Then we don't come across a lot of flat shapes in our lives. We live in a 3D world, and so the things that we encounter are typically three-dimensional, like these polyhedra right here. Now, a polyhedra can be defined by its properties, right? So, for instance, this shape right here, hold on a second, let me get my pen. This shape right here, we can look at it and say some things about it. We can say, well, it's made up largely of rectangles. In fact, it's made up entirely of rectangles, right? hopefully we'd also notice that it has two congruent um, parallel bases. And what do I mean by that? Well, here's a base right here, and I don't know, this shape keeps flipping by my perspective, depending on how often you blink. If the shape flips on you, just blink. I can see a base on the bottom and a base on the top right now. And so it has congruent parallel bases. These bases will never cross each other, and they're exactly the same size. Hopefully you can see that. This shape, this solid, this polyhedron, also has faces that are parallelograms, right? So if we look at its face right here, at least it looks like this to me. It may have flipped on you. I don't know. Give your eyes a blink and let's see what happens. There's one face in the front and then another face in the what I'm calling the back. But again, you know, it might look different to you depending on how your vision is flipping on you. Okay, so two parallelograms that are faces. And we call a shape like that, a prism, right? P-R-I-S-M. And there are all sorts of different kinds of prisms, right? And there are all sorts of other special polyhedra. Obviously, this isn't a prism, nor is this, right? Because it doesn't have the same properties. But we reviewed them in class. Let's see what you remember. I want you to, in just a second, pause the video again and see if you can, on your paper, put some numbers down, and next to each number, tell me what shape this is. So what shape is this? What's this one? On your paper you'll do number 1, it's this. Number 2, it's this. Number 3, it's this. Go ahead and see if you can do that. Now I will give you a hint. These two may look the same, but they're actually not. So maybe I'll give a special reward to people who can tell me the difference between this one and this one. Go ahead, pause the video now and see what you can do. Okay, if hopefully you did all right, and again, I'm not going to give you the answers. I'll go over that tomorrow in class when I see you. We're going to be looking to find the surface area of this particular shape, which was a rectangular prism, right? And when I'm talking about surface area, I'm not talking about how much this shape can hold. That's a question of volume. I don't want to know how much stuff I can put inside of this box. What I really want to know is, what do I need to cover the surface, all the surfaces? This surface, you know, how much space am I talking about if I'm covering this surface here, and the top of this, let's say, box, and the side of this box, and this side of the box, and the back of the box, and the bottom of the box? That's a lot of space. How am I going to cover it all? So my question to you in closing, just as we're about to leave this video, your journal topic when you come into class tomorrow will be this. How would you find the total surface area of this shape using what you know about area of basic shapes, of plane shapes, and using what you know about the properties of polyhedra? How would you find out the surface area of this entire shape? Now notice I haven't given you any measurements. I just want you to tell me what your plan is in words. So as you come into class tomorrow, you whip out those journals and you tell me, what is your plan? How would you go about finding the surface area of this entire shape? All right, well, thanks for watching. That's been about, I don't know, maybe almost 9 minutes. I'll see you in class tomorrow. Get some good rest, and it's step up day, so don't worry, don't forget about that. We'll begin our math class at 9:30. See you then.